Hello, everyone, and welcome back to the fourth edition of Winter Data and AI Meetup. Thank you very much for joining us today. Our speaker today is Adem Kaya, Senior Data Scientist at EPAM Turkey. In this talk, we will discuss what really happens when AI moves from experiments into a real production system. Building a prototype is usually the easiest part. Making it reliable, safe, and scalable is much harder. You will hear about real challenges like keeping AI accurate, managing costs and latency, and making sure AI systems behave safely over time. If you enjoy this event, please like and subscribe to support our community. Your feedback helps us to improve our future meetups. If you have any questions during the presentation, please write them into the chat and we will discuss them with Adam after the presentation part. And now let's start. Adam, the floor is yours.
Thank you, Alex, for the introduction. Hello, everyone. My name is Adem Kaya, and as Alex explained, I'm going to address the elephant in the room, which is going to production. You have probably heard about the MIT report in which it said that 95% of AI pilots are failing. But the fact is that they are not failing because of like LLM intelligence. It's like the other way around. Currently, LLMs are getting smarter and smarter, but the issue is business alignment, in which most AI pilots are not business aligned. For this, in my talk today, from prototype to production, ensuring safe and reliable AI, we are going to walk through like a prototype that we prepared, and then we are going to say, okay, we got into production. So let me uh, introduce myself first. Well, I'm a senior data scientist at EPAM Türkiye. I started my journey developing what we call today small language models like BERT, and those Roberta sentiment analysis models back in the day, where there was not those like general purpose large language models in which we fine tuned for sentiment analysis, classification, and this kind of stuff. Then came the time for large language models when we don't have to like train large language models, or let's say develop large language models, but it's the other way around. We have to build applications around large language models in which they produce business value. But in this switch, I noticed a lot of discrepancies between the two approaches. In the first approach, I was like more of a data scientist, but in the second approach, I was thinking more of like a software engineer or a product manager. So here's the agenda. First, we are going to introduce our let's say prototype conceptually, and then we are going to increase the problems, like going step by step and saying we had this problem and this problem, how to fix this, and etc. The aim is not to be comprehensive in terms of like encompassing all of the problems that might face us in production, but the aim of this presentation is just to address the elephant in the room, in which it is like like AI applications are not just proof of concept applications, in which we have to think about a lot of the components. Some components in my presentation might not be in some applications. Some applications might have all of the components. But as I said, like the aim is just to address the elephant in the room, which is going to production and aligning with business metrics. So first of all, we are going to address drag and knowledge base problems, safety and guardrails, error and tools, in which it is like the kind of tools that we interact with, latency and cost, which is one of the major problems that face a lot of AI pilots these days, and of course, observability. And we are going to conclude with some Q&A session. Day one, we have our proof of concept. It was working. We talked with some of our stakeholders and they said, nice, it's working. But here is the issue. We were testing our application on a local LLM, for example, or Llama. We were like doing RAG over an internal knowledge base in which it has 1 to 2 PDFs maximum. We are doing some tool calling, but since like we are like doing tool calling, as a single person, like it's a single developer or two developers who are just testing in different times. And we have like we are interacting with some external APIs, like for example, search or fetching, let's say, archive PDFs or something. So our stakeholders liked the proof of concept and said, okay, let's go to production. And here starts our nightmare. So here's an overall, like, let's say, conceptual, let's say, diagram. We have our LLM application, and it interacts with our RAG knowledge base. It interacts with some external APIs like search, archive, whatever. We have some tool calling, which are local. They are not MCP. And we have our local LLM, which is mostly open source. So we got into production and we faced our first problem in which users, like our knowledge base started going big, and users started asking, what should I do in case of this case? So the LLM retrieved the data, and there was two answers. In this case, if it's before 2025, do A. If it's after 2025, do B. But since we are using like some sort of token-based chunking, in which we say like the max chunk or overlapping chunking, the max chunk we say 100 tokens, the date in which it says before 2025 or after 2025 is missing. So the LLM sees two answers, and it says like, what should I do? Like, I'm not sure. Should I do A? Should I do B? Like in a good scenario, it might say, okay, I got two answers, like maybe you should do one of them. But uh, if we use a different, like a different type of chunking, in which like we are using semantic chunking, in which it chunks the whole, let's say, the whole chunk of the idea, and we add metadata filtering, for example, filtering by date or something, or we add some context resolution in the system prompt. So we say, let's say, prioritize answers that are after 2026, or prioritize answers that are in 2025 or something. So this way, we can fix some of the problems that are facing us in terms of two answers for the same question. But like for sure, if we were not using LLMs, or we were, let's say, there is a product manager, for sure they know that there is a policy in order to do this. So we have to encompass this policy inside of our application. That's cool. We fixed this problem, but our user count started increasing, and our like knowledge base side just started exploding. And since we in the proof of concept phase, we were testing over, let's say, one or two PDFs, we were not seeing this problem, which is the nature of proof of concepts. For this, we started like having a hard time retrieving like relevant documents. We started having off-topic answers appearing in the context fetching phase, and our RAG quality just dropped, even though like we have more information, right? It should be like it should, if we have more information, we must have better results, but it's the other way around. It's not working this way. So the root cause for this is that uh, vector indexing is different than database indexing. So in terms of normal data, like let's say relational database indexing or document database indexing, it's the same type of indexing. But in terms of vector database indexing, it really depends on the amount of chunks that you have. It really depends on the dimension of the vectors, uh, the type of indexing, because like it's not fully deterministic, and some indexes needs refreshing each period of time, like whenever you add more data. Some indexes are dynamic, but some indexes, for example, that are based on k-means, they need like refreshing each period of time. So we have to keep that into mind. So we choose, like after reviewing, we choose, for example, a better index type that suits our knowledge base needs. We also tune the distance metric, because like unlike relational database indexing or whatever other database that we are using, there is no such thing as distance or threshold or something. But in vector database indexing, there is threshold that we should determine. We also like add hybrid search, in which instead of hitting the vector index directly, we say let's fetch, for example, uh, let's fetch data related to medical use cases, or let's fetch data related to HR use cases. So instead of the first use case, in which we have chunk one, chunk two, chunk three, and all of this kind of stuff, and it's too many for the LLM. It's overwhelming. Uh, Not to mention if the number of retrieved chunks are not does not suit inside of the context length of the LLM. So for this, we enhanced our indexing approach in order to be more relevant. That's the first thing. The second thing is, like, first we added metadata filtering that allow us to just, for example, let's say that we have two type of documents. First one is related to HR. The second one is related to medical use cases. So if we let's say if we are asking only for HR and we first filter by HR, medical use cases documents are, for example, let's say 50,000 documents or something. So we ruled out all of that. So this way we might have more precision over what we are retrieving. So hybrid search, vector indexing, two things to visit when there is irrelevant results in the retrieved things. So nice, our knowledge base is working good, and there is no problems with the knowledge base, but we started noticing some really strange patterns in our, let's say, logs or something. So the application that we designed is designed, let's say, for internal support, but we noticed that some of the users are exchanging log messages with the bot, which is not what it intended for. And some users are trying to role play and push it off domain to maybe gain some, let's say, classified information or something, saying that I am the manager of this company, I am the CEO of this company, and I know everything. So there is no like, uh, so it's okay to give me some classified information. And we sometimes catch the LLM, for example, inventing wrong information about the policies in our company, or let's say about uh, medical diagnosis or something. And there is a thing in this type of problem, which is hallucination. Once it starts, it keeps going, which is what we call the snowball effect. So the snowball effect is essentially, if you start with something wrong, you keep inventing more and more wrong facts. For example, I remember back in the day when the beginning of open source large language models started coming out, the instruction aligned one. I asked it a question like, "Who is Adem Kaya?" And I remember it saying that uh, Adem Kaya is someone who the authorities are looking for. Please inform them if they see them. Probably they wanted to hire me at the time. That's why it said that. But after that, whoever I asked about, it said that it's a friend of mine, and the authorities are looking for them as well. Whoever, like I mentioned some really famous people, I mentioned some really non-famous people, and this is what we call the snowball effect. The earlier that we catch it, the better. So we also started noticing some attack patterns, ignore previous instructions, behave this way, this way. So for this, we start adding, for example, let's say input classification, which we call guardrails, and we also add output classification or output guardrails, maybe some grounding for the answers of the LLM with our knowledge base in order to reduce hallucinations, or maybe some grounding with, let's say, if we are talking about medical facts, let's say we can ground them with search. So we search the internet saying, is this correct? Uh, we also, like most of the LLM providers, allow us to enforce, let's say, rules in the system prompts. So the LLM knows that if there is a rule in the system prompt and there is a rule in the user prompt, the LLM must prioritize the system prompt, which the user does not have access to. So at the beginning, we had our user interacting with our LLM, and the LLM just spitting out information. So the user does not have any filtering, the LLM does not have any filtering. For this, we add input guardrails, output guardrails, and we are aligned with our policy. We are not allowing manipulating the LLM at all. So if it's unsafe, it does not pass, and we maybe return some generic message saying that uh, this it does not allow, like this does not conform to our policy, please try again, or some fixed message. AWS allow us, for example, there is AWS guardrails, I believe, and it allows all types of, let's say, warning, blocking, or sending a message, etc. So after we fixed these issues and we like there is no hallucination, it's not possible to eliminate hallucination at all, but uh, at least we eliminate, let's say, 90% of the cases, because eliminating like a lot, let's say a huge percentage of a hallucination is really easy, but once you get to the 10%, it's hard. Anyways, so our knowledge base is working, the inputs, the outputs are working as well, but we started having other type of errors, which are like reliability. We noticed that 5% of our calls are network errors or timeouts due to the LLM. So the model, or sometimes the model refuses to generate a structured output, which is in JSON format. Uh, and like one of the services or the API, for example, the APIs that we are interacting with just returned 403 blocked. So all of the components that are working with this API are down. So we are banned for some reason that we don't know about. And some of the tools we defined are returning some strange error messages that the LLM can't know why they are happening. So mostly they are invalid parameters, or let's say timeouts or something, and users are just frustrated. They are just, it doesn't work, and they are not going to say anything else. They will only say it doesn't work. So for this, we introduce a retry policy for our LLMs, because there is this thing that there is no LLM provider uh, on Earth that is going to provide a service level agreement in which they say 90% of the time our service is going to work, expect 10% to be offline. So for example, AWS S3 give you a service level agreement, which is I think 99.59 of the time that S3 is going to work during the year. So expect 43 minutes that it's not going to work in the year. But LLMs does not provide that. So we are the service level agreement. We are the ones who are going to, let's say, encompass these problems. So we add the retry policy to the LLM, and we never fail on the first try. Also, like once we investigated why we got banned from the uh, from from the API that we were interacting with, we noticed that there is like a rate that we should conform to and we should respect, which is, for example, archive maybe 5 requests per second. If it's 6, we are going to get banned. So for this, we add a API rate limiter for our tools that respects the rules of our external APIs. And maybe we use some sort of caching for frequently asked questions. And also we add some sort of, for our tools, we add clear messages that the LLM can understand. So if it's a missing parameter, we say it's a missing parameter, please try again. So the LLM can just add this parameter or something. So at the beginning, we have timeouts, like getting blocked from external APIs, and the tools are just not working. But in our use case, we have our retry policy for our LLMs, we have our rate limiters for our external APIs, and we have some structured error handling in our defined tools. And this way, we eliminated most of the reliability issues that we were facing. So this is one of the most important problems that most stakeholders care about, which is latency and cost. So after we fixed all of the issues that we were facing, now we are facing, first of all, our users are frustrated. Second, our stakeholders are frustrated, which is the worst place a developer should be in. Users are frustrated because they are like, we are waiting a lot. Like it takes 2 minutes to get an answer from the LLM. And stakeholders are frustrated because they said, you said that it's going to cost this amount of money, but it's skyrocketing right now in terms of the cost. After we started like investigating the issue, we decided, for example, to increase the number of threads of our application in order to reduce the latency. But there is an issue. We hit the LLM token rate. So we tried to increase the token rate, and we got to our stakeholders saying, please increase the token rate. And they said that, okay, but if you increase the token rate, this is a management decision. It's going to increase the cost. So reduce the latency without increasing the rate limit. So we finally noticed that we might be able to introduce a router inside of our LLM gateway, which is something that we are going to introduce, in which it inspects the LLM input and the user input, and depending on the type of request, for example, if it's saying hi, you shouldn't send that to GPT-5 Pro. That's going to cost a lot. So if it's going to say hi, maybe send it to a really small LLM. That will reduce the cost and the latency as well. So two birds, one stone. Also, like after inspection, after like inspecting the logs, we noticed that one region of one LLM region is getting really slow globally. So after we removed that region, we started having big improvements. So not only like routing for big small LLMs, but as well detecting which LLMs are getting are having high latency, and probably routing to another, let's say, another region or something. For example, AWS, there is that thing that is called cross-region inference, in which if a region becomes really overloaded, it just directs you to another region, and you can define the regions if you have, for example, some sort of policy that say that you are going to be all LLM calls must be in the United States or something. So for this, we introduced health checks and routing. We have our cache. We introduce some Redis vector, and we have like routing, and we are removing like bad LLMs. By bad LLMs, I say slow ones, and like we reduced costs, we reduced the latency as well. So UX and prompting, we fixed the issues that we are facing in latency and cost, and we got some feedback from the user, and it says that the app is useless and it doesn't understand me. It doesn't do anything. So we inspected the logs, and we noticed that many users write with broken grammar or shorthand or with some sort of dialect. And during the POC, since we are really good in English, we were testing on really good grammar. So we are not missing punctuation, we are not misspelling any words, we are using grammar, and we are explaining in a step-by-step what we want. So we were surprised, like it was working. Why it's not working right now? That's why, because like we didn't simulate real user behavior during the POC. So maybe we adjust the system and user prompts to, for example, normalize the grammar. So, or rewrite query, which is query or enhancement or query optimization. And most importantly, like test on real use cases. So let's say app no work, what do, help please. So like how the like most LLMs will understand this, but like back in the day they didn't understand that. So LLM like what does you mean, like what do you mean, what do you want? So maybe we normalize grammar, we write queries, and then we pass it to the LLM. And before this presentation I checked, there is 1.5 billion English speakers in the world. Only 400 million are native speakers. So you have nearly 1.1 billion people speaking English as their second language. So expect them to make mistakes, expect them to misspell words, expect them to not write punctuation at all. So after all of these issues, we decided that observability is really important. So we decided to integrate an observability tool that lets us see each component we are interacting with. That's latency of LLMs, latency of each API call, latency of the tools. If we are like interacting with like an API or a tool, inputs and outputs of each tool. We also decided to add LLM as a judge in order to understand whether like the responses are aligned with the business or not. But after we integrated business LLM as a judge, we noticed that one day we didn't change anything. We didn't change the prompt. We didn't change the code. Nothing changed. But our metrics showed that our judges scores dropped by 15%. And after inspection, we note like we understood that the issue was that one of the providers silently changed the model weights. Like probably, most providers do that. So for this, we decided that we shouldn't rely on a single provider and we should adjust all of our system to be provider agnostic. So if one provider changed, one provider is failing, we just switch to another provider. So on our observability tool, like provider just silently changed, we noticed that immediately thanks to the observability tool that we had. So right now we have like observability. We are provider agnostic, so we can switch providers whenever we want, and we have portable prompts and models. So the prompts are not just fine-tuned to specific provider. For example, they work on OpenAI models, but they don't work on Google models. No, they work on, let's say, Anthropic, OpenAI, and so we are testing before the changes. So we have maybe some regression tests against prompts or something. So at the beginning, uh, we had this simple P or C that we are like interacting with local LMs and RAG, external APIs, and tool calling. But right now we have our let's say well-architected system that has guardrails. We have the prompt optimization layer. We have LLM gateways. We have caching for some components. Our optimized RAG system is working just fine, and we have our safe, reliable, and optimized response. And everything is shown on the, let's say, observability tool that we are integrating, whether that's LangFuse or any other tool that is available. So here is the thing. AI production environments are inherently different. So first of all, we should ask some questions before going to production or during production. Well, first of all, do we even need AI? So please, if it's a simple thing, just don't use AI at all. Prefer software, like let's say traditional software over AI when the problem is solvable using traditional software. Second, did our latest prompt change or any change in the system improve or break the system? Like we should have some prompt regression tests over some data set that we have. We should maybe have some A/B testing, or we have prompt versioning in case if the prompt didn't work, we just get back to the other prompt. So each prompt should be versioned, and for example, each prompt must have, for example, this prompt had this test results over our regression data set. Does the models that we are do the models that we are using align with the business domain that we are working with? So for example, there is some models that are good with code, like for example Anthropic, as far as I know they are good with code, and there is some other models, for example maybe Gemini, that are good with the medical domain. So probably we should have, like before choosing the provider, we should have some, let's say, a benchmark for our use case that gives us some sort of, let's say, insight on which provider is the most important one. Do we track the latencies of our components? That's really, really important. Like tool calls, DB queries, time to first token, tokens per second. All of these must be tracked because like latency problems are nightmare problems. If you have latency, you should know each, like where is the bottleneck? Like for example, is it the model? Is it the database connections, for example? So some database connections takes forever to have. So maybe you have to have some connection pool that is open all of the time. And are we blindly following trends? This is bad because whenever a new thing comes out, it doesn't mean that we should integrate it. It should be tested. And LLMs are not a hammer for all nails. So if it's similar to how once microservices architecture just popped out, everyone started switching to microservices, but then they noticed that their system must be monolithic instead of microservice driven. So each system is different, each tool is different. We shouldn't integrate everything to all projects. So conclusion, LLM app development is really different than classical machine learning development. We have new team makeups, like we have prompt engineers, backend engineers, DevOps engineers, backend and infra. Backend is mentioned twice here. Anyways, so we built a toy rocket that flies great in the backyard during the POC. But going to orbit is a different game. The first attempt will always blow up. But if you have those things in mind before you go to production, maybe you can address them before going to production. Maybe you don't need all of the components. Maybe you need more components. But the idea, as I said at the beginning of the presentation, is just to say that uh, AI application development or going to production is really, really different. Building the POC is the simplest thing to do, but going to production is different. So thank you for listening. If you have any questions, like you can always send me an email or find you on LinkedIn. And now we can start the QA session.
Yeah, thank you very much, Adam, for interesting presentation. Yeah, we
Thank
have
you, Alex.
questions. Let's move to them. Uh, yeah, so first question from the chat. Um, yeah, you mentioned that. Do companies really understand their data before doing AI?
Well, it's not like that companies don't understand their data. It's that it's a new domain. So no one knows the data. And here comes, like, for example, understanding how this data should be parsed or how this data should be chunked from our side as AI engineers or software engineers or whatever you call us. So this is the job that we should be doing, which is understanding the company data before going into the application that we are developing.
Mm-hmm. Another question from the chat. Maybe two questions. How to notice the altering behavior of users? How to
Nice.
catch the hallucination snowball?
Well, most likely LLM as a judge, I would say that's the first solution that comes to my mind. In terms of, for example, how to notice altering behavior of users, guardrails are your best friend for that. So, for example, let's say that you are using Bedrock guardrails. they allow you to determine how many times you hit the guardrail. So, for example, triggered the guardrail. So, for example, you might have on CloudWatch saying that yesterday, uh, this guardrail, which is, for example, a guardrail from prompt injection, was triggered 10 times, but today it's triggered 60 times. So there is a real difference between yesterday and today. So you can forecast, like there is some sort of time series that you can see. And luckily, like for example, Bedrock, AWS, and most likely for Azure and GCP, I'm not sure, uh, show you that there is like a jump between those values. That's for user behaviors. As for hallucination, I would say that you would have some sort of a data set that you would test your application over, let's say on a weekly basis or something. But in order to prevent it, you add, for example, grounding with, let's say, RAG, or grounding with internet results or something. So that's how you address those two problems.
Mhm. One more question. So you also mentioned that uh, maybe that not always businesses need AI really, but they want it. Maybe you can give some examples where businesses wanted AI, but or maybe already created a AI solution, but in reality, it wasn't required.
Yeah, so it doesn't come to my mind right now, like an exact example, but we see them on LinkedIn all of the time. So, like you see like uh, an Apple-powered AI, so or a
Washing machine
CR,
with AI.
yeah, washing machine with AI, like or refrigerator with AI. You don't need AI with your refrigerator. Just open it and close it, and that's it.
Yeah, that's correct. So maybe also looking on all these difficult, like complex systems and projects, you can say what tasks will always need humans.
Well, that question, like the answer to this question differ by who you are asking. But for me, I would say that ethics, like for example, if you are using AI for defense purposes, probably the final decision maker should be a human, not an AI, because if it makes mistakes, there is human lives on the stake. That's one thing. And the second, I would say, for example, uh, I would say anything relate that can alter a human life shouldn't be addressed using AI. University admissions, let's say loans that are given by banks. And for this like comprehensive list, I would say that read the book called Weapons of Math Destruction, in which I think I don't remember the author name. She addresses all of the use cases that are being used for like in AI and that are altering human lives.
We have one more bit complex question. Have you tried implementing multilingual chatbot to actually support users in their native language, taking into account that the majority of them are not native English speakers? If you have, then what are the findings? Does supporting key languages multiply the complexity by K when it comes to metric collection and sense making?
Okay, good question. Well, first of all, I didn't see such a system in which it's using multiple languages at the same time.
Mhm.
But what I noticed in terms of what is being used in the industry, if there is multiple languages, at the beginning you switch the language because it's a nightmare to let's say compare uh, the same application with two languages. As you said, it multiplies the complexity by how I
Mhm.
don't know.
Mhm.
We should test that. But for example, like we saw that at the beginning of like large language models boom, where there's some research papers. It says that the same question, the LLM fails to answer it in a specific language, but answer it really well in English. So I would say that just isolate those two things.
Mhm. Also, I have such a question. So you explained all this like complexity of
Mhm.
systems around AI, and so does it mean that all like pet projects or like small projects or even startups who want to start who want to use AI uh, like will fail because like creation of these all systems whole systems require real like complex
Engine.
platform and thinking about it in advance, so you cannot just create some page. Yeah, will definitely fail.
It wouldn't be right to say that most startups or companies that are using AI will fail. MIT said that 95% of the applications are failing, but the issue here is that if you are aligned from the beginning and you have all of these concepts in mind at the beginning of your startup, you really understand your business domain, you really understand your users, and you are not just like, let's say, enthusiastic. I have the POC, we have done it. The moment you say we have done it, you failed.
Yeah.
Yeah.
Yeah, and maybe a question that we ask here regularly. How do you see AI world in the next years?
Okay. Well, like for me, I see that AI adoption is going to increase. Uh, it, it's true that we are in an AI bubble. I'm not sure whether it's going to explode in a really bad way, but like year after year, we are going to understand the limitations of AI and what could be done and what like could not be done. So, for example, I see that personalized education is going to be a thing in maybe 10 years, 15 years, or something, because that's something really, really important. And that's what I use AI the most for, which is personalized education, just explaining to me things in a way that I really understand, or just omit some problems. For example, explaining Spark, Apache Spark, to a machine learning engineer is different than explaining Apache Spark to, let's say, a junior university student because they don't know machine learning. So that's where, for example, personalized education or, for example, personalized coaching or something. So it's going to have greater and greater adoption, but not in the way that we are thinking that AI is going to replace everyone and we are getting out of jobs or something.
Okay, understand. Yeah, agree with you. Yeah, I think that's we can conclude our session. Yeah, thank you very much, Adam, for interesting presentation. Yeah, thank you very much, everyone, for joining us today. If you like this presentation, or maybe you don't like, please rate this talk on the talk page. Also, please give speaker a badge. It helps us to support our speakers and the community. Also, on the talk page, you can find the recording and download the presentation file. Yeah, thank you very much, Adam.
Thank
See
you,
you.
Alex. Thank you,
Yeah,
everyone.
bye.
See you. Bye.